Thank you.
Yep. So did everybody pull the latest code? Yes, no.
Yeah.
I put it in general in CodeSeoul. Yeah. Seollal Bootcamp 2025 backend. Did everybody do that? Please answer the question. Yeah. I'll wait a couple of minutes. Okay, so I am going to talk about SQL Alchemy. And SQL Alchemy is the library in Python that allows you to interact with databases, right? SQL Alchemy can interact with almost, I think, any database, Postgres, MySQL, any relational database, as long as you provide the database driver for it. SQL Alchemy can connect to it, and it will allow you to emit SQL queries and get whatever the result of the SQL query back to you. So the first thing that we have to learn, right, is that to make a connection to the database, we first need to have database running. And we did that with Docker Compose for the entire morning and a little bit of the afternoon. And the code that we have, it also needs to know about the like database settings, right? Normally, we would not put the database username and password in plain text. We would have them in a secret manager somewhere, and then like get it from the environments. It would be, I think, it would be something like OS, get env OS, kind of like get and Byron like something. It would be something like this, right? It wouldn't be exactly like this, but it would be something like this. You would get it from the environment as opposed to just having it plain text like here. But for simplicity's sake, we're just putting it here, right? So first, we have the database like settings here, right? And if you've connected to a database with pgadmin, you realize that you have to put in the username, the password, the host, and the port, and all that kind of stuff. We have to do the same thing, right? So we have to build the database URL, because what a database is basically just another program running on a computer somewhere. It can be in the same computer that you're using right now, which is what we're doing. But in the actual, when we actually deploy it, this database could be running on another computer somewhere. And to access that, we need a link to this, a URL, so to speak, to this database, right? So what this connection provider does, right? It creates an engine. So this database engine is responsible for creating a connection to the database. And we will use that connection to send SQL queries and get results from the connection, right? So as you all noticed, when we do a SQL query and when we execute it, we get a result from it. So yeah, this is what the connection does for us. So first, we're going to get the connection string, right? Hold on, this should be, just we already have that, settings, get DB URL, right? Because it's basically the same thing, right? We get the database URL, and then we create the engine. And then using the engine, we make a database connection, right? And then we are going to use this to do we do this here. We can see here that this is a fast API thing, but what this basically does, right, if you're not using depends, which is a fast API thing, what it's doing is just basically the same as this. It's just calling the function, right? and then it's getting the connection, right? Just getting the connection, and we are using this connection to do database stuff, right? This is essentially what's happening. So let me just put this back. Hold on. Yeah, went back too much. So all you need to know is that this engine creates a connection, and we're going to use that connection to do database stuff, right? And the good thing about SQL Alchemy is that one, it is very widely used. So there's a lot of reference material online. And two, there are many correct ways to use SQL Alchemy. And in this bootcamp, we're going to teach you a more SQL-focused way of using SQL Alchemy, right? You can use SQL Alchemy as a ORM, a object relational mapper, but we're not going to be doing that. We're just going to work with the raw database connection and SQL queries. So yeah. And another good thing about SQL Alchemy is that if you know SQL well, using SQL Alchemy is going to be much easier because we're going to be heavily using the Query Builder APIs. A Query Builder API is basically just lets you build SQL queries using just programmatically, right? Normally, when we just write SQL, right, we do stuff like select from product. Since we have a product table here, we can do this, and we can make the connection, the SQL connection here to execute this, right? But the problem with this is that you can make mistakes, right? Because this is just strings and text, you can make mistakes, and we don't want to do that. So the solution that people came up with is a query builder, right? And what a query builder does, it just allows you to call functions that will eventually become a SQL query, right? So the first thing that we'll cover is the creating stuff. So in SQL, we learned that to create stuff in a database, we have to insert, right? We have to insert. But instead of just writing insert, let me just remind you what it is. SQL statement. Right. Normally, we would write something like this. We would write something like this, but we don't want to do that because, as I told you, you can make mistakes and all that kind of stuff. We have this table here. I will talk about how to define tables later. But from this table, we call the dot insert, and then this will basically, this insert here will turn into this, right? And then this values here, right? It will take the dictionary. So what model dump does, right? It takes this Pydantic model, and then it turns it into a dictionary. And then this returning, what this means is what this means. Insert into a table these values, and then return everything, right? So this is what this SQL statement means. And what our statement means here is, what this means is insert into product table the values to be defined, and then return all the values, right? Because normally the insert statement, it just inserts into the table and then just does not, and then it ends. If it succeeds, it just doesn't return anything. But since we want to return all the, since we want to see all the values that have been created, returned to us so that we can serialize it and then return it, we do the returning statement, right? So this is what it essentially means. Insert values into the product table and then return everything, right? So after we create the statement, so creating the statement doesn't execute the statement, right? After we do that, we execute the statement, and then from the result, we get the first result. Since we only inserted one, so we get the first value, and then we do whatever you want to do with it. So this is how you do inserts in SQL Alchemy, using the SQL first approach. Any questions so far? Yeah.
Why this first value not last? Yeah.
Well, we insert only one thing, and it will return only one thing. So we will keep. So I mean, the result will be something like this, right? It will be just like some kind of like row object, but we only inserted one thing.
Yeah.
So it's only going to return something like this, and then from the result we can take the first value from it.
Not last.
First and last is going to be the same. So I don't know what the question is.
I mean, have a row. There is return all, right?
This?
Yeah.
It means returns all the columns. Yeah, not all the rows that are in the table. We return the row that has been inserted.
Oh, okay.
Yeah.
And what is the purpose of returning that rows after insert data?
So after we create the record, we want to return to the front end to show what we have created. Right? Front end is going to take what we've created and they're going to show it on their page. Right?
Isn't it better to separate that method to create project and that return data set?
Why do you want to call the API twice? You can just create and then return it in the same operation. What's the benefit you get from creating and then nothing gets returned to the front end? So front end doesn't know if it's been successfully created or not. And then, you can just create it and then return the created results. Why should it be different? Why should it be two different ones? And also, when we create something in the database, usually the database primary key is also generated with the database row. And front end has no way of knowing what the newly created database row ID is going to be. So front end needs to know that, right?
If you have some parameters like aging and amount of rows, and you will return just first row.
This is for creating. This is not about pagination. Yeah, creating is not pagination. You don't need to worry about pagination. Pagination is a separate API.
As I said,
yeah.
For example, when the user sees exact page with exact amount of data, and after creating, you said that after creating, we just return new data.
Yeah.
And that means that he will see just the first row.
Yeah, one thing got created, so we're going to return that one thing. Yes, I don't know what you're confused about. Yes.
I didn't understand. So, why should we return data after insert data?
So what do you think should happen?
I don't think that it's necessary to return data after creating data.
You have to show that it's successfully created.
Created is just created. No need to return the data back.
It depends on case.
So in a database, there usually something called a primary key. It identifies that the row is unique in the database, and it's usually generated by the database, and it's usually we don't know what the database key is going to be in the actual server, right? The code here, we don't know what the
I mean, you were saying about optimizing queries, yeah, but
This is nothing to do with optimizing queries. This is just about how we use SQL Alchemy to create a row in the database. Yes. We can talk about all this later. Let me just go through everything. Yes.
You say insert and return star.
Yeah.
It's the same thing as saying insert and then saying select star.
Yeah. It's just all compressed into one statement. Instead of having to do two statements, you just do one. Yes. So pagination, we'll just think about that later. Get detail. Select where. This should look familiar to you. So what this turns into basically, select from product table, right? This is basically what this query is. We're going to select all the rows, right? And where the ID is equals ID, right? This ID, we're going to get passed in from somewhere else. It could be like 1, 2, 3, 4, 5, 6, 7, 8, whatever. So yeah, this is going to return one thing, one row, whatever that matches to ID. And then we're just going to get the first value if it exists. If it's not none, we will just like return it, right? This is what we do for select. So it's very similar. So the API for SQL Alchemy Query Builder is very similar to SQL. So that's why I said knowing SQL will make this very, very easy, right? Very, very easy to learn. So update, right? The update statement is update product table. So what this turns into, right? Set, let's say, what is the value? Hold on, the update request. Let me just have this here. Name equals name. Description. Description. Image. Image. Price. Price. Stock. Stock. Where ID equals ID, right? And then of course returning everything. So what this is, right? This update turns into this, and this where is this, and the values here, it turns into this SQL statement, right? And the returning, it becomes this, right? So what this does is we build a query with the from the product table, we update, and then we just set all this. And then after we do all of that, we're going to execute using the database connection. And since we only just updated one value, like one row in the table, we're going to get one thing from the result. So we get the first thing, and then we're just going to like return it, right? So this is just how you use SQL Alchemy for creates, updates, deletes, and selects. For deletes, delete is also pretty simple, right? So what this turns into, right? What this turns into is delete from a product table where ID equals ID, right? Yeah, so basically what SQL Alchemy does, it takes the code, it turns it into SQL, and then it just sends it to the SQL the database's URL that we have set here, right? That's what that's basically what it does, and it's just really, really good at that, so that we don't have to write stuff like this by hand, because this is gonna like cause mistakes, right? So delete, update. So yeah. Any questions about SQL Alchemy so far?
I have a question.
Yeah,
So the ID we are talking about is like primary key, right?
it is the primary key. Yes. Yeah.
Ultimately, is that Python library you import?
Yeah, it's a Python library that you can install. So we already have it defined here as one of the dependencies. And if you do want to install everything, you just do this, right? The command is in the README, right? Command to install all of the dependencies. Right, so this is basically how you select, update, query, and delete. Pagination requires a bit more stuff to do. So this is a bit difficult to see. So I'll just explain how this query ends up being like. So we first start with our select. We're going to select everything from the product table, right? And since this is a pagination query, we may want to do some filters. This can be anything that you desire.
Anything I desire.
Anything you desire, you know? Yeah. And then we are going to paginate, we have to limit and then offset. And this can be done very easily using the API here. So this limit whatever here becomes just whatever here, right? The offset becomes here, right? It just gets compiled into a string, right? Right, and this is a pagination query. So since this is a pagination query, we are not going to have just one value returning all the time. It can be multiple values. So instead of doing mappings.first, we do mappings.all to get a sequence, a list of row mappings. And then we just turn that into something that we can respond back to the front end with, right? And since this is a pagination, hold on, next page. What is the next page? This seems to be more like,
Sorry, that's kind of messy.
yeah, that's kind of messy, but there is going to be a cleaner implementation that I will show you later. Yeah, so this is how you do pagination, but yeah. It looks almost like SQL, which is very, very just comforting, I think. You don't have to think about, hey, maybe can I do this? You can just try it and it will work most of the time. A pro tip that I'm going to share with you that helped me a lot when I was using SQL Alchemy. Let's go here. No, not here. Here, right? So I told you that the SQL statement, right? It can be a select, insert, update, or delete, right? It can be compiled, right? A compilation means like compilation means it can be just turned into a SQL string, right? So it will so any arguments you pass in will be compiled with the statement that you have here, that you have prepared here, that we're going to turn into a string. And through here, you can check that the query that you've built with SQL Alchemy is the query that you expect. So this is really good for debugging. When you're not sure that the query that you wrote is correct, you can just literally print it out and see that the query just works the way that you expect, right? So this is why I do prefer using this query builder method over other methods, right? Questions so far? Questions? Yes?
Get count is just counting all the possible answers, right?
In the pagination?
Yeah, in the pagination.
In the pagination, let me go back to pagination. So what the pagination count query is going to look like, if it existed here, right? It would be select, count. This is a built-in function in SQL from product table and where, including any filters that we decide to put in. Yeah, so this is what the count query is, right? It just counts whatever the number of results are from the results of the query, right? Without limit or offset. Yeah. Any other questions? Any other questions about SQL Alchemy? Yes?
Yes, can we all of the my SQL commands or functions included?
So yes and no. Yes and no. Stuff like the very common stuff, which is common among like different relational databases, like select, from, and where, and join, it's all supported. But some like database, like SQL dialects, are very specific and so are not supported directly. But there are ways around using like specific database like functions in SQL Alchemy, but I won't cover that right now, but it is possible. Yes. So in Postgres, there's a lot of like JSON functions, and you can also use that in SQL Alchemy. There is a way to do that. And in MySQL, there are also JSON functions, but they're different from Postgres functions, but you can still use them in SQL Alchemy. Right. Questions? Any questions? Cool.
Well, thank you, Jason and Nani. That was awesome.
Yeah.
Now let's take a quick Very well done.
Thanks.
Man, you guys killed that one. That was great. Or at least the parts that I watched, you guys explained very clearly. Your screen.
Yeah, wait. Wait a minute.
What's that?
I'm just what I have this tree.
No, why did it switch? Insurance.
Okay, take the guys back with me, Nadia, and we are gonna jump to data modeling, and we're gonna make it fast because our schedule quite left behind. So in data modeling, there's no kind of demonstration because it's very abstract. It's very abstract and it's theoretical. But it's necessary because it can shape our mind how to think about database, and in the future probably you can design the database. So it's about philosophy, principle. It's kind of like that, philosophical layer, but it's a little bit boring. I'm trying to cover a whole book and what I learned for 2 semesters in less than 1 hour. So bear with me. It's kind of like that. So what we're gonna do is review about what is relational databases, and also thinking about entities, what it is, and also data type, normalization, types of relationship, foreign key or key, basically, indexes, and database migration. So as we already know, relational databases is kind of like database with table as the shape of the database, have a structure like row and column, and also each table should have schema, or you should define what kind of value in each column, whether it is numeric, whether it is text, whether it is block, binary, or something like that. And also it should have key, whether it is primary key and foreign key, but primary is necessary, it's mandatory, it's obligation, it's imposed. You know, like it's kind of sin if you don't have any primary key in a table. It's sin, it's mess up, no way. It can I really emphasize it. It's very important. It's kind of like that. And also, let's go to thinking about entities. What is entities? It's basically it's an object. For example, if you design a database for a school or a university, you think about the object inside the university. For example, like student, professor, or administrator. And each entity has attributes. Is for example, like, oh, students. We need to know the name of students. So the student have name. Or we need to know the student gender. Sorry. Yeah, we need to know. Or we need to know date of birth of the students. Everything that important to your business process and your system. Everything you should define it. For example, here we have three kind of entities. Perhaps it is for e-commerce, like user, product, and order. Like in user, you absolutely need user ID. Otherwise, you don't know which user is ordered a product, right? And also you need to know username. Otherwise, the user cannot log into your system, and also password, and also email and address. How about user boyfriend name? Do we need it? No, right? It's not important to our e-commerce system, right? User hobby. Do we need it? For e-commerce system, I don't think we need it unless you want to create AI recommendation systems, kind of like this. So find your business requirement, your what kind of system you want to build and what things that important to the system, and define it to the attribute of your objects. It's kind of like that. Any questions so far? Okay, here there is an example. For example, like user ID, I define it as integer, perhaps 1, 2, 3, 4 or something, and I mark it as PK. Okay, that's primary key, something that important, mandatory, and unique. And also name, I can define it as variable character, because perhaps probably name can be combined as like numeric, alphanumeric or something, and also email is also can be alphanumeric and also text here. You might curious what is the difference between variable character and text. Both of them cover alphanumeric. We'll talk about it later. Here, this is the common data types that engineer or IT professional use to define database. Here in numeric, we have small integer, big integer, and decimal. Decimal to cover like something behind comma or something. The difference is about the allocation of bytes inside the memory. Like small integer has limitation to cover the number, for example, up to 10 million or something, but big integer can go to 1 trillion or something. So this is a character here. Character only can cover alphanumeric, only alphabet. I think so. And also variable character and text, both of them can cover alphanumeric, but text is unlimited. There is no such kind of allocation for text, but variable character has certain limitation in terms of memory, kind of like that. And also variable character can be used as indexes to optimize the performance of databases, while text cannot be used as index. And also Boolean, true and false, there is certain of type of data, like it's only true or it's only false. And also this is date, time, and date time. This is very common, very, very usual to see it on databases, on any databases. Because for example, like in commerce, we have transaction date and time. So every action, what happened inside the system usually has when it happens, and it always be recorded as date, time, or date, or only time, or something like that.
Character.
Yep.
Is a fixed length of character. So if you say, oh, it's a character 32, then even if you only enter one character, it's still going to take up 32 characters of space. The empty characters are just padded with blank data. Okay, so varchar is variable length character. So even if you make a maximum 32 and you only enter one character, it'll just store the one character. Usually you want varchar, variable length character. Usually.
Then we'll go to relationship here, key. Actually, there are three types of key: unique key, primary key, and foreign key. But primary key and foreign key, both of them are unique. I mean, like every key should be unique. There's no duplication in it because it's identification, especially if you do join or if you do conditional in your queries, something like that. And it should not be null. Means that if you design a column as a primary key or foreign key, absolutely don't let it blank. Otherwise, it's wrong. It cannot be work. And also, what else? Primary key also has identification. I got question before about how if I delete cherry, there are 2 cherry in my tables. Of course, because I don't have any identification, it's kind of like machine gun, like shooting everywhere. Something like that. That's why we need identification. Which target I gonna do operation with it or something like that. Foreign key is kind of like proof that this table has a relation with other table. It's kind of like, do you think that product and order are related to each other, or product with the user are related to each other? If,
Yeah.
huh? Yeah.
The product and order are related to each other.
Yeah, but product and user is not related. They are not related to each other, user and product. But how can we identify product and order related to each other? See in the table, is there any product ID in the order table? It's kind of like that. We can prove it with the foreign key existence, whether it is there or not, kind of like. Here are the things. You can see, like I said to you before, here there is a product ID here. Please be kind to me, okay? Product ID has relation with the order table, but product ID cannot have any relationship with customer. It's kind of like without any transaction, how can customer be related to products? No way, right? Based on your logic, it doesn't make sense, right? That's why there is no any relationship. And also orders. Usually in e-commerce, do people review product or their orders? Their products, right? That's why review table has a relation with the products table. That's why here in the review table, there is a product table. And you see here, there is such kind of sign. We will explain it later because it's about the degree of relationship. It's kind of like, here the thing, aggregation, degree of relationship. So 1-to-1 means that it's kind of like one object only can have one relationship with one object. 1-to-many, it's kind of like one object can have many relationships, like polygamy, something like that. Yeah, I try to make the room heat up with multiple objects. And many-to-many is kind of like open relationship, free. You can do anything. So here in the example, it's like one user only can have one profile. One user have 2 profile is forbidden. That's why when you sign up to a website, if you sign up with the same email you used before, usually they refuse it because they have this 1-to-1 policy. And also a user can place multiple orders. In Coupang, we can order multiple times. This is 1-to-many. And also many-to-many is kind of like products in multiple orders or vice versa. Like products can be ordered in multiple orders and multiple orders can contain many products. It's kind of like that. That's why here means that one product can have many reviews, and this is many product can be in many orders, and also here one customer can order or can have many orders. If I'm not mistaken, that should be how we will read about it. Is there any questions so far? If we don't have any question, let's move to normalization. Normalization is the way to think, to define how many tables we have after we identify objects in our system. It's kind of like that. Because relational database has asset principle. A stands for atomicity, means that the data should be chunked into very small part. So that's why they can fit up to the tables. So we need to do normalization. There are three types of normalization. First is the first normal form, second normal form, and third normal forms. The benefit of normalization is make your design pretty, compliant to standard, and also efficient, and also reliable. It's kind of like that. This is first normalization. So you can see here, before normalization, we have two phone numbers in phone numbers column. Guys, you cannot do that. Otherwise, it's hard to identify. For example, for example, you want to call John Doe because there is kind of failure in his order. That's on the customer ID. But in terms of John Doe has two numbers. If the database like this, what we are gonna do? Probably we will call John Doe twice in phone number A and phone number B, and it's not efficient. That's why we need to split it. It's kind of first normalization. Second normalization is kind of like, if you see this thing in the Microsoft Excel file, probably it's normal, but for database, it's not normal. You need to do normalization because here there is partial dependency, where partial dependency, like when product can be searched by two by two primary key. It's kind of like that, and non-primary key should only rely on one primary key. I mean, like, if you want to search product info about the explanation of something, but you search in by order ID, it doesn't make sense. It should be with product ID. That's why in second degree of normalization, you split this table into two, order tables and also product tables. Is there any question?
So what you mean is you should have just one primary key. I mean, just one unique thing in your table.
Yeah, for being primary key.
Yeah. You can have another unique thing table, and you have another thing right here.
And then,
Both order ID and product ID are unique, right?
yep.
So you don't want that?
Well, it's better to split it. I mean, like, because well,
So in this case, right, you have, this is kind of a join where an order contains multiple products, right? In this specific scenario is not really showing that, but order and product are two separate entities. And this is what was meant by the thinking in entities part. An entity, like an order or a product, they're distinct things, and therefore they should have their own table. If you need to combine data about them, you can do that through a join. Does that make sense?
Thank you, Rich.
Yep. Yeah.
It's composite key. Sorry, I forget to explain about composite key. Composite key is the term for calling two unique ID from another unique ID. That's composite key. Here, the things that product name should only depend on product ID, so it violates second degree of normalization. And then the third degree of normalization, there is redundant, okay, duplication of something, inefficiency in here. Like, for example, can you imagine if we add more employee, for example, Anna, David, and they belong to HR department, and in manager column, John Smith will be written twice more, like here at John Smith and also John Smith. It's very inefficient, so it's better to split it into the department table where HR, IT, and then the employee table will be like this. So it's kind of like department is the only thing that employee table is linked to. It's kind of like that. Ooh.
You could probably even split this more, where you could have the manager in the departments table could just be a reference back to the employee table, again, right? The difference is that when you do this kind of splitting, right, you'll end up having duplicates in your employees table for the department value. And anytime you see that, you want to split it into a separate reference.
Tersebut. And then go to the next index. Yeah.
The table, one order is saved in one table. You have the same order ID in multiple rows, different product IDs, right? So then the order ID is not unique.
In that case, so let me see. Can I draw something here?
And can you restate the question?
Yeah.
So when you make an order, you have multiple products in the same order. So you want to make a table from that order. It's going to have multiple rows with the same order ID, but different product IDs.
Ah. That's
So
transaction.
the order ID is not unique.
It's a many-to-many.
Huh? Many. Oh.
So, you want me to get this one?
Yeah, if you want.
So what you're describing is a many-to-many relationship, because many orders can have many products, right? So one order can have many products, and then one product can be a part of many orders, right? So when you have this many-to-many relationship, what you need is not transitive table, or not transactional table, a transitive table,
That's the
but it's also called a linking table, right? So if you would have basically, you'd have your product table, right? And you'd have your order table, and then you'd have kind of a middle table, which we call our linking table or our transitive table. And that would just have the product ID and the order ID. And then you just have the product and order IDs duplicated to get whatever matchups you need between the two. And in this way, you have in the linking table, you have many entries in the linking table to one product and many entries in the linking table to one order. And kind of through this table, you have a many-to-many. So you basically use two one-to-many relationships to create a many-to-many relationship. Good question. So the question is, would the linking table have a primary key? This is kind of a point of debate. Some database designers give the linking table its own just counting primary key, and then they have an index. They have a compound index on both the product ID and the order ID. Or some other designers do a compound primary key on both the product ID and the order ID. I'll let you do your own reading on which one you prefer. Personally, I prefer to do a compound primary key, but only on linking tables. That's the only case where I ever do a compound primary key. Okay, or composite primary key, sorry. Composite being where you have more than one column in the key. Now, one thing to keep in mind with composite keys or composite indexes, either one, they're ordered. Okay, so if you are filtering, say your composite key is product ID and then order ID, if you try to join by order first, it's going to be slow. Okay, because it's going to have to scan the whole table. So usually what I do is when I create a linking table, I have a composite key in one direction, and then I have just what I call a reverse index, which is the same columns, but where the composite, if the composite primary key is product ID, order ID, I then create an index that is order ID, product ID, because then whichever direction you're joining from is still fast. Does that make sense? Cool. Sorry.
Oh, it's okay. Thank you. Back to presentation. After having all normalization done, and don't worry guys, after the presentation, and I will recommend you books to read. It's very like Holy Bible of database, something like that. So we move to index. It's kind of like that. Primary index, unique index, cluster or non-cluster index. So when, like 10 years ago, when I started my first job in Huawei, I was assigned to network operation team center, and then I should monitor transaction tables about telecommunication, something. And then when we do query only select, it takes like 1 hour to complete. Really, it's kind of like torture me. Like I had to work until 12 p.m. just to retrieve data and convert it to the report, the Excel report or something. It turns out the database, each table didn't have any index. So index is very important to improve the speed of data retrieval. It's kind of like this. Like, for example, can you imagine like you have bookshelves and then you order the book based on the title in alphabet order, ascending, like A, B, C, D, E, F, G. When you do such like, oh, I want to have Harry Potter, just go to each section, right? But what happens if you put the books randomly, not based on the title? You have to search one scan. That's happened with the SQL interpreter, something like that. So indexing is very important. We have a primary index, unique index, and cluster index. It's kind of like that. Yeah.
So you guys have read books. Has anyone looked at the index at the back of the book? Well, what does the index look like? Can someone describe it to me?
Order with number of pages, and they have charts.
Yeah.
Chapters.
Yeah. So basically, you have all the keywords, and then what page those keywords appear on, right? An index in a database is like an index in a book. Okay. So for each value that appears in that column, it'll track the value in a sorted manner, and then it will reference which row that value appears in. All right. So let's say you have a database table with 1 million people. Okay, and you have an index on their name because you want to search by them by name at some point. Okay, so let's say you want to search for someone named Zachary. Begins with the letter Z, right? If you were to just go through the table, it's a random chance on where it ends up. And if that Zachary appears at the end of the table, you're screwed, right? But with an index, because all the values are sorted, right? Now Zachary's at the end, right? So you're like, crap, that's going to be very slow to find because it's at the end of the index, right? But no, indexes are usually B trees, okay? So you use a binary search with this. So what'll happen is you go, okay, what's the middle of the alphabet? I don't actually know. I'm just going to guess. Does anyone know what number's in the middle of the alphabet? I genuinely have no idea. I'm just going to guess it's L or something. All right, let's guess it's L. I have no idea. So it starts with L, and that goes, okay, is L less or more than Z? It's less. Okay, so then we'll get rid of A through L. Okay, what's between M and Z? I have no idea. I'm going to guess like R or something, right? Okay, is Z less than R? No. Okay, so we're going to get rid of M through R, right? And basically cut your data set in half each time. This is a binary search. And you end up searching much, much, much faster. Okay? And then you can find Zachary. Once you've found Zachary, you can look at which rows he's in, and then you can do a direct lookup on those rows. Okay? That is way, way, way faster than just scanning the whole million records of the table. Okay? Because you do a binary search on all the possible values, and then you have a direct reference to which rows you need to pull out. Okay? This is how database indexes work, and they make things much, much, much faster. So you might be thinking, well, great, why don't I put an index on everything? Well, indexes may be very fast to read, but they incur cost on write. Because anytime a new value appears in your table, then it has to rearrange your index, right? So let's say, someone new enters your table, and then your table has never had the name Aaron before, right? That gets added to the beginning of the index. So that's the shift to the whole index to make room for Aaron at the beginning, right? So indexes incur a write penalty, but they provide a great read speed boost, okay? So you don't just want to add an index on every single field, okay? You only want to add it on fields that you're going to search by, okay? Fields that you're going to filter by, all right? But you absolutely want to use indexes for performance purposes. Otherwise, like Nadia described, you're going to be sitting waiting an hour for a query, which is absolutely absurd, but honestly, I'm not surprised. There's a lot of people out there who don't understand databases. Now, for those of you who have a little bit of familiarity with backend stuff, you may be like, why are you teaching us SQL? I can just use an ORM. That's how you get that 1 hour query bullshit, okay? A lot of backend engineers are like, I don't need to know SQL, that's old stuff. Like, no, you're an idiot. It is important for backend engineers to at least have some amount of understanding of SQL, have some understanding of how the database engine works. And using ORMs is okay, depending on certain use cases and behaviors, okay? In like something like 80 to 90% of cases, ORMs are totally fine, okay? But in that 10 to 20%, oh man, they suck, okay? Personally, I don't like them, but I've used them and they make development a lot faster. And in cases where performance isn't a big, huge thing, it's totally okay. We have not taught you ORMs today, okay? But they're easy to look up. You can go over them. SQL Alchemy has an ORM component, but we didn't cover it. We only covered the query builder. But it's important that you understand this data modeling stuff too, because even if you're using something like an ORM, if you don't know how to organize your entities properly, if you don't know how to do your relationships properly, your one-to-one, your one-to-many, your many-to-many, or if you don't know how to do your indexes properly, it's going to suck no matter what you're using to build it, okay? So this stuff that Nadia has covered has been very, very important. Read up more on indexes, read up more on relationships, read up more on normalization. Again, this is only an introduction to everything. There are way more normal forms, and there's also normal forms that aren't even actually that useful, but they're good to know about because sometimes they are useful. So do supplement your own studies beyond what we've covered today. Sorry, we got on a soapbox for a second.
Thank you, Rich.
Yep.
And this is the last. It's about database migration. Actually, I don't want to cover it, but I don't know why it is. It was on the. It was on the skeleton of the presentation, but I think thinking about database migration when you design database is good because by the time your product or your system gonna be changed either from the business logic logic side or from the technological stuff, kind of like that. For example, like 10 years ago, this bank using Java, so and then this year they're gonna upgrade their technology, for example, to be JavaScript or something. And then you need to know how to migrate your database, kind of like that. But don't worry, these days we have a database migration service, kind of like that. But I hope that you guys read more about database migration. And then this is my recommendation about database books. It's very comprehensive guide, both of the books. It has like 100, not 100, not 100, no, 1,000, up to 1,000 pages. And they teach you to be database designer. It's very recommended and cover everything. But in this database system, it's a little bit difficult to digest because they use mathematical, mathematical, wait, not connotation, annotation, no, notation, mathematical notation to describe something related about database. I strongly recommend this. That's all of my presentation. I give it back to BG. If any question, welcome.
And no questions. Cool.
We're going to continue.
Yeah. So we covered a lot of theoretical stuff. So we only really talked about how we select stuff from the database using SQL Alchemy. But now I'm going to talk about how we actually define the tables and then flex the tables that we defined in the code into the database. So if you remembered, hold on, let me just Google Meet. Google Meet. Let me just go to the Google Meet.
And Nadia, can you make sure to mute your, either leave the Google Meet or mute it? That is fine. Oh, sorry.
Done.
Thank you.
Shut off the screen. Where is my code? Where is my code? Where's my code?
It's probably up here.
Oh, it's here. Okay.
So don't forget to share screen in Google Meet.
Yep. I'm going to share the screen.
Great.
Allow. So let me reiterate. So we covered a lot of theoretical stuff about databases. Now I'm going to cover the practical stuff again, because that's what we're here for. We talked about how we select stuff, right, from the database, how to create, how to insert, how to select, how to update, all that kind of stuff. And I mentioned this product table very often, but now we're going to learn about how we actually define it. So in the code here, in the product, we can see that we import SQL Alchemy. And since we're going to use SQL stuff from SQL Alchemy a lot, I'm just going to import the entire thing and then give it an alias, SA, short for SQL Alchemy. And we can see here how we define the table, right? Since we're not using the ORM, we're just defining the table directly. We take the table object, we create the table object, we give it, this is the name of the table, right? Name of the table. And this is make sure SQL Alchemy is aware about this table existing, right? And then afterwards, we define the columns, right? So besides selecting, updating, deleting, and modifying, those are called data modification languages, DML. This turns into basically DDL, data definition languages. We're going to define how a table is going to appear in the through SQL, but we're not going to write raw SQL, right? Raw SQL will be something like this. It would be something like create, like table, like product, and then like And the column would be like ID, primary key, big int, auto, increment, name, varchar, 255, description, text, image, varchar, 255, price, it would be numeric, 12 and 2, and then stock, it would be, oops, this shouldn't be description, right? Image, price, stock, integer, and then this would be what are the nulls and not nulls. This is not null, not null, blah, blah, blah. This would end up something like this. Yeah, SQL Alchemy will take this and then it will turn it into a data definition language SQL like this, right? But as I said before, writing stuff by hand is certainly possible, and I've done it before, but I wouldn't really recommend it. Using something like this that's predefined like this, we won't make mistakes and it will make development much easier. But how do we take this, right, and then put it into the database, right? Because that means we have to run this before the server starts, right? We have to do that. So the tool that we're going to use, right? The tool that we're going to use is called Alembic, right? It's called Alembic. And did everyone activate the virtual environment and then install all the packages? Did everyone do that? Yes? Did everyone do that? Cool. And to just check, hold on, let me just open up Docker. Okay, let me just open up Docker PS. Does everybody have the Postgres database running on Docker? On port 5432. Does everyone have that? Cool. So Alembic is a tool that allows you to run database migrations through code and through the command line, right? So the Alembic, this is the configuration file. I don't use this too much, but basically after you get Alembic, right, after you install it, you do something like Alembic init -t async, since we're using an async database, and then the name of the folder, right? This will create a Alembic, this will pre-generate this like Alembic folder, and then just a bunch of code for you, right? So you don't need to do that. It has already been done for you. I'm just telling you what needs to be done if you're setting up from scratch, right? What you need to do, right, in the end, this is more configuration, right? So there is a way to automatically generate the database navigations on your own, but since this may be a bit like confusing for you, I'm not going to teach you that. Instead, I'm going to just teach you how to configure the configuration string. So what Alembic needs to know, right, is what is the database URL, right? So this database URL, we got it from here. This is also used by the application to run the SQL queries that we write through SQL Alchemy. But we also need to tell Alembic what to use, right? So let me to reiterate. Inside the Alembic folder, there is the m.py, and in the run async migrations folder, right, we get the configuration. This is just the default getting the configuration part. And from the configuration, the SQL Alchemy URL, right, the configuration is just basically a dictionary of a string. We set the SQL Alchemy URL as the URL that we have for the entire application, right? So this is what it means. And after we have that, what you need to do, right? I'm just going to delete this, right? Wait. Let me just Alembic downgrade base. All right. Okay, cool. I'm just going to delete this. I'm just going to delete the migration that we have here. So After we have Alembic, right? After we have Alembic configured, which is already done, you don't need to do it. What I want you to do is go to the README. I have here, yeah. So to create a new migration file, which will be run by Alembic, you need to do Alembic revision -m, your migration name here. So right. So I'm going to do is Alembic revision m add product table, right? And it will create a file for you. You see inside the versions folder, inside Alembic, we created a new file, right? We see that, right? Are you guys following along? Do you do this command? Alembic revision add product table. Yes, no? Okay. After that, we're going to make the commands, right? We're going to do OP. OP is the Alembic. I don't know why they call it OP. They import Alembic as OP. Maybe it's short for operation, but I think that's why. So let's do OP dot create table, right? You see here, right, that in OP, when we do this, there are a bunch of like functions that we can like call: add column, alter backend, alter table, blah, 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 create primary key, blah, blah, blah. From here, we're only going to do create table, right? And from create table, right, what we're going to do is models, product. We are going to take this. Hold on. Create table. Hold on. Let me just check if I did it right. Let me just check if I did it right. The deleted table. Yeah, that's correct. Okay. So so we define the migration here, right? We're going to tell Alembic to create the table, and we're going to give it these columns and this name of the table, right? And we can see that it's the exact same, almost the exact same, minus the metadata as here, right? So all we need to do is just copy paste minus the metadata, right? Then we get it here. And we also have to downgrade, right? op.execute, wait, op.delete table, drop table, product, right? Right. And now you have a fresh migration that you can run, right? And this will already be done for you, but just in case, this is how you do it, right? Any questions? Someone had a question. Yeah.
What is
So Alembic manages database migrations for you, right? So we have the definition of the table like defined here, right? But it's not reflected inside the database that we have running, right? We want to sync the two so that they're the same. Alembic will connect to the database, and then it will create the table for you, or alter the table, or do anything. That's what it'll do for you. It is a tool for that. Yeah.
Also, when you do stuff with Alembic, it also kind of tracks progress. So let's say like, you can track all the changes you've made to the database over time. And it actually stores a little bit of information in the database to track what changes it has and has not made. And it also allows you to, if you try to make changes to the database and things don't go well, it can roll back. So that's why if you go back to your migration, we have this downgrade function, right? So if for some reason, when we try to do our upgrade, things don't look the way they're supposed to, you can write some code to actually undo those changes, if possible. And you still have to define what those undos are. But Alembic tracks which they call each of these files a migration. They track which migrations have and have not been done. So if migrations have yet to be done, they'll all get executed. Or if for some reason you need to roll back, need to roll back to a certain point, it will undo them in order. So it's a nice way to kind of progressively change and track changes to your database. Does that make sense?
So it's a gift for database?
Not really. Not really. It's close, but it's not really. Yeah.
Yeah, it serves the same function, but in a very different way. Because you can, if you step through the migrations, you can get to kind of different history of the database in terms of structure, right? But the problem is that, you know, your database is otherwise just ongoing used, right, by users on the live application. So you have to be very careful. Whereas Git, it's just you're tracking the state of code and that's it. There's no other moving parts. So does that make sense?
Yes.
Is that accurate?
Any questions? Yes.
I want to. That's all. I want to ask about seeders. Should we write seeders on inside these migrations?
What do you mean by seeders?
Kind of fake that data before we run. Before we, for example, we want to see that our project kind of demo version, and we need kind of hundreds of products, fake products.
So if you're just doing a demo and you want to just populate the database, then yeah, you can do that, and you can do that through Alembic. Yeah.
In this folders or
yeah, in this folder. So here, you can execute SQL like raw SQL like directly here. You can do op.execute, like sa.text, right? Insert into product, you know, blah blah blah. You can do that, and so whatever like thing you define here, Alembic will run it. So yes, you can do that if you want.
And to be clear, you probably don't want to put test data in your migrations because your migrations ideally would be run in production, right? The idea is you write your migration, you run it in development, right? And then you test everything. And then when you go to production, you're running that same exact migration. That's one of the main benefits of Alembic, is it tracks which migrations have been applied. And as long as the migration you applied in development is the same migration you apply in production, you should get the same exact result, right? But if you're using it for test data, well, you don't want that test data to go into production. So now things get a little bit tricky.
So I had this problem at work, which is exactly what you're talking about. So what I did is servers usually emit events like application has started, application is shutting down, right? So I made what's called a events listener. It listened for the application start event, and after the application start event was received and the environment was development or local, I would execute commands that would create dummy data, right? It would live differently from the migrations, but it would do the same thing, right? It would wait until the application is started up. It would check if the environment is local or dev, and then it would create data, right? That is a way to solve that problem. Yeah.
Or ideally, if you're using tests, if you're doing testing, you should be automating that testing. And then when you're automating that testing in your setup or teardown, you should be doing your data work. And that way it's all part of the test environment. But there is another case where you actually want to work with data in production using a migration, and that's the case of lookup tables. So let's say that you're doing a web application for cars, right? There's a limited number of colors that a car can be, right? So you have like white, black, blue, green, orange, whatever. And that's not going to change really. That's not going to be data that your users are going to write to, but you need that data to exist in the database for lookup purposes. And in that case, that would make sense for data that you would want to insert as part of your migrations.
Okay, let me wrap Alembic up really quickly. So after you've created the migration here, right? What you can do is, I put this in the README. Alembic, where's the Alembic? So the idea is that you will be constantly creating these migration tables as your tables get added, removed, or like modified. So you'll have many, right? So what you'll do after creating a migration is you're going to run Alembic upgrade head. This will upgrade to the latest version of migration that you have, right? Right, you see running upgrade and this hash value here refers to the hash value here, which is also inside the file name here. So, right, it means that the migration successfully occurred, and now the database has a product table. So this has to be run like before the server gets run. So what Beach wrote here is, yeah. So for dev, you activate it, you compose up, you upgrade, and then you run, right? So most like fast API running scripts, it will have the Alembic upgrade head before you actually run the server. So that's how you actually do run the migrations. Do try running Alembic upgrade head, and if there are problems, let me know and I'll try to help you. Yes. This is the end of the migration section. Yeah. Yeah.
Thank you, Jason.
Yep.